is Python-based object-oriented program for inventory management of hybrid electric vehicles. The inventory management of vehicles information like manufacturer, model, year, color, and base price can be electronically done using tools like the object-oriented programming, and in my case would be Python-based. Project aims to develop Python-based template for hybrid electric vehicles inventory management, which can be used, for example, by the dealership staff. In this project, I call it the staff member, the inventory manager, to quickly review specific information about the hybrid electric inventory. The key input parameters for the project here for the code I developed include vehicle manufacturer, the model, the year, the color of the vehicle, the battery capacity measured in kilowatt hour, and the range of the vehicle. Um, in writing the program, the object-oriented program, I used lots of classes, as I will talk about later, and inheriting classes, or what we call them, the subclass, and I use methods and instances, and in one of the module I use dictionaries and lists. Um, these are list of my references which I used. Here is the hybrid electric vehicle. By the way, I'm showing here the Jupyter notebook. I also generated by charm from the project. So the program here has 6 modules, as you can see here on the right-hand side in figure 2. The first module has a profile of the dealership inventory manager. I will talk about that later. And then the second module has summary of key information. I chose, for example, a 2020 Toyota Prius black color, and this is the hybrid electric vehicle. Module 3 has the hybrid electric vehicle base price and the sales price. Module 4 will provide check for any inconsistencies in the hybrid electric vehicle records. For example, 2 cars have all the information are the same, but even the price and the ID of the vehicle, but they are from different years. So apparently this could be a mistake in entering the records. So this module will check on that. Module 5 has a comparison of the base price of, for example, 2 of the hybrid electric vehicle, the Prius, one in year 2019 and one in year 2021. The last module, module 6, will calculate the number of Toyota Prius black color HEVs here in the fleet, which is present in the record. So that's the 6th module of the program. Figure 3 shows you the parent classes and subclasses, or the inheriting classes, which I used in the program object-oriented program. So at the top here we have the class for the inventory manager, which will give the profile. I will show that next. The profile of the inventory manager who entered this information into the database. I have a class for the HEV information. You get specific information about the vehicle, and under that I have 2 subclasses which call the attributes from the main or the primary class. One is called HEV, getting information and give you additional information like the capacity of the battery and the range and so forth. This one, the HEV fleet, will give you information on the number of vehicles in the fleet of the particular year, production year of the vehicle. On the left-hand side, I have one class for the battery. Talks about the battery information, capacity, kilowatt hour, and the associated range. And I have a class also here which is the sum of the base price plus tax. Then the output here at the bottom, you get an entire tally of information like the hybrid electric vehicle, you get the year, the manufacturer, the model, the color, and the vehicle ID. You get short description of the vehicle, just very quick identifier, manufacturer and model. You get the vehicle odometer mileage as it sits in the parking lot of the dealership, for example, how many miles it has already. The battery information, capacity, kilowatt hour, and the associated range in mile. And then if there is upgrade of the battery information, like from lower capacity to higher capacity, what would be the new range versus the old range, which has a lower capacity of the battery. So here is the first module, which is, I called it here, the profile of the dealership inventory manager. Here is the structure, so it has a class and it has two methods, the init method and then the inventory manager information. When I run this small module here, module 1, I will get the following information. The first name and the last name of the inventory manager, email address, and the location. I just use my name here. The second module here is a summary of the key information of the specific model and year Toyota 2020, black color, and I have here a class called HAB information info, and it has its own set of methods. So I'm defining here the init and the attributes in it, which has manufacturer, model, year, color, the ID of the vehicle, and then I have get HEV information, and I have other methods as you see that here. Now I have another class for the battery, and it has its own methods, which will tell you the, for example, the capacity 6.5 kilowatt and the associated range 100 miles. If you go to higher capacity, the range will be higher. Like here, if the capacity is 85, the range will be, of course, higher than that. So, and then the print statement. So when you run this in Jupyter, you run it. So I get this summary information. Here, for example, the year 2020 Toyota Prius, black color, and this is identification number. A short description would be Toyota Prius, and then I have the initial mileage of the vehicle, 50 miles on it. And here is the capacity 65 kilowatt hour battery. The associated range also will be printed. And then if we have upgrade from 65 kilowatt hour to 85, the range will be higher, as you can see here. And instead of 140, went up to, from 140 miles, it went up to 27. Then I have module 3 for the base price and the sales tax. When you run that, you get here information in US dollars, 29,600, that's the base price, and the associated sales tax, $8,000. Module 4, check for inconsistencies in the records, as we can see that here. I have two similar Toyota Prius, and I'm asking, are they the same car or of the same year? And the answer here is false, because one of them is year 2021 and the second is 2019, but both of them, they are the same vehicle and the same even vehicle ID, which means that we have an error, so we get here false. Module 5, compare the base prices of two Prius of different model, different year. So when you run that module here, it will give you information about the base price for the 2019 model is 26,300 $26,300 versus if it is 2021, it's $29,600. Lastly, Module 6 will calculate the number of Toyota Prius of certain color, black color here, how many we have in the fleet. So when I run this class and the associated method, and I can get here the output of executing this cell will be 25 hybrid electric vehicle of this type in the fleet in the dealership. As a wrap up, I provide a description of the problem. It's essentially start creating database for the vehicles. Description of what I have used. I used Python classes and subclasses and methods and instances and dictionaries and lists. Some of the interesting thing which I learned doing in the project, I always wanted to know about object-oriented programming, so this was good opportunity for me to practice that and dig deeper into the literature and our the lecture notes and our textbook about learning about the object-oriented programming. I showed the results in action here, and then the main limitation here is that my samples are very limited, or the examples which I give here, very limited examples, but once we establish this template, it can be expanded and we can add more to it. These are just the references I used. I also created here using PyCharm. I'm going to go here and stop this and then share the PyCharm here. So this is, I will also submit my solution here, which is the file .py, the Python file which has the script of the program which I wrote, and if I execute it, it will be here in action. Overrun, and you can see here at the bottom, you get all the pertinent information about the inventory. So that's about